moving on to example 2. Find the area of the region enclosed by the parabolas y equals x squared plus 3x minus 10 and y equals 6 minus x squared. Notice they didn't give us any side boundaries this time. That, again, that implies to me that the parabolas here are going to intersect, and the points of intersection are going to help create the boundaries. So if I start by going to my calculator and typing in the two equations, x squared plus 3x minus 10 and 6 minus x squared. You'll pay attention when you're graphing these. You know, y1, y2, maybe y sub 1, y sub 2. If you were to put that on your paper, maybe that would help. Once I get it graphed, I can tell also. I mean, this obviously is going to be in blue. That's going to be red with our color calculator screens, but even then, sometimes we forget what we typed in. I'm not sure exactly where they intersect, so if I just do a zoom 6, as standard zoom, from -10 to 10 on x and y. There's my blue one, which I can't see the whole thing. And there's the red one. All right. So obviously, you can see there's a region in here that's being intersected here. So again, I can't see the bottom of the blue, but what I need from this, the piece of information, is I need to know what's on top, what's on bottom, and the left and the right boundaries. That's what I'm trying to gather, the information I'm trying to gather from this. So from this, I can very clearly see that the second graph, the y2 graph, is on top, and the y1 is on the bottom. Alright, if I didn't know that, if I just go here to calc and intersect, because I got to find the intersection points anyway, right? So calc 5. Notice that when I'm on a graph, you see the blinking cursor right there, it tells me up top what graph I'm on. So if I didn't know which one was top, which one was bottom, when I'm doing this calc intersect, I can very clearly see that the y sub 1, x squared plus 3x minus 10, that one is the bottom graph. Just looking at it, I can see that. All right, when I'm trying to find intersection points, I need to identify the curve. So first curve is y1, second curve is y2. It doesn't matter where I'm sitting when I pick those. The guess, though, is important. I want to guess near -4. The x value of the point of intersection is what I'm guessing. And -4, -6, exactly right. So there's one intersection point at -4. The other intersection point happens over here. Looks like 2, but maybe it isn't. So again, if I do second calc, choose number 5, intersect. Again, I'm picking the curves. It doesn't matter where I'm at when I'm picking the curves. Picking y1, enter. Picking y2, enter. Then I'm guessing near the point of intersection I care about, which is 2. Hit enter, and that's 2, 0. So again, what information I need to gather from this calculator is what's on top, what's on bottom, what are the boundaries. So I very clearly figured that out, the top, the bottom, and the boundaries. So I can construct my integral now. The area between the curves is going to equal the integral from -4 to 2, always go the small to the big, of the top 6 minus x squared minus the bottom x squared plus 3x minus 10. Each time construct your integral correctly, top minus bottom from left to right boundary. So, once again, I can simplify as much as possible. -x squared minus x squared makes -2x squared. -x minus 3x makes -4x. 6 minus -10 makes +4. With polynomials, that happens quite often, where you just get, you know, this minus that and that kind of stuff. So just simplification. If you need to actually distribute that minus sign first to be able to look at everything before you combine them, that's fine. I think most of us are capable of going through just each power at a time and figuring it out. So now if I differentiate, we get -2x cubed over 3 minus 4x squared over 2, better known as 2x squared, plus 4x, going from -4 to 2. If I put 2 in first, I'm going to get 8 times -2 is -16 over 3. 4 times 2 is going to be -8. 4 times 2 is going to be plus 8. And put negative 4 in next. Negative 64 times negative 2 is positive 128. Negative 4 squared is 16 times negative 2 is negative 32. And negative 4 times 4 is going to be minus 16. And again, that minus is distributing through. We have a common denominator of 3. So if I go ahead and get everything with a 3 on the bottom, minus 8 and plus 8 cancel right there, so I'm allowed to do that. Okay. So obviously negative 16 over 3 is already taken care of. This will be minus 128 over 3. This will be plus 96. And that'll be plus 48. This isn't looking right. Look like more area than what we're going to get. But
shouldn't it be plus 16 for one?
this should be positive, shouldn't it? No, it should be negative.
No, I'm saying like for your dx thing, your second one when you did it, it says it's 6. Wouldn't it be 6 plus 10?
Oh, it should be 16, shouldn't it? Thank you. That's where the problem is, because that answer was going to be way too slow, too small. There we go. 16x. That just messed up a whole bunch of stuff, didn't it? Start over. All right, we'll fix it now. All right, so that's plus 10 plus 6 makes plus 16, so that makes plus 16x, which makes, again, if I put 2 in first, negative 16 thirds minus 8 plus 32. If I put negative 4 in, I'm going to get negative 64 times negative 2 is going to be positive 128 thirds. 16 times minus 2 is minus 32. And minus 4 times 16 is minus 64. That's much better. Okay. So now if I distribute the minus, I get a common denominator of 3. Negative 16 thirds, that'll be minus 24 thirds plus 96 thirds minus 128 thirds plus 96 thirds and plus 192 thirds. That looks more likely. So, let's see, negative 40 and 128 is negative 168. Positive, 96, 192 plus 192 is 384. And 384 minus 168 is 216. Comes out to 72. That's much more reasonable. All right. So, the main problem here is simplification for me, so maybe try not to do like I did, but do like I did after Logan fixed me. But again, create the correct integral, simplify correctly, evaluate correctly, and all should be good.